Hey guys, let's do a quick review over domain and range since we're focusing on that this week. If you remember the video I covered or showed y'all in class about functions, and you had a function machine. I think it was the metamorphosis video. You had a function machine, you had an input and output. So that's basically what this is. So domain is all X values. So all your input, that's your input. And then you have your range, which is all your Y values. So the key to remember is X is your domain and Y is your range. All possible X and Y values will consist of this. So if you have f of x is equal to 3x. So whatever this is, you're going to be your range or your output. And then this x right here will be your input. So whatever your x value is, you plug it in here and you will get an output. So let's look at an example of how this will look on a graph. So let's say I had a graph. This is my X, horizontal is X, vertical is Y. Again, domain is your X values and your range is your, let me erase this. Your range is your Y values. Right? So let's say I have a line segment and I want to determine what is the domain and range of the line segment. So let's say I have a point here. And it goes up to here. Okay. So I want to go ahead and right now to refresh your memory on something you have learned in previous grades. So y'all remember in, I think it's 5th or 6th grade, you had a number line, right? And you had to write an inequality that best fits the number line. And let's say you had a open circle on -2 and you shade it to the right. What will be the inequality for this example? So again, this circle here is open. So that means this number is not included. This -2 is not included in your inequality. So that means you will have -2 is what? You want your X value. Let's say this is X. You want your values greater than -2. So any value greater than -2 will be a possible solution for the problem. So -2 is the smallest number. So -2 has to be less than X. So that means our X value has to be the largest number. So what I'm trying to get you to understand is if it's open, it's going to be inequality which is less than or equal to. So if it's open, it's going to be less than or equal to. So what do you think a closed circle will be? A closed circle will be included, less than or equal to, greater than or equal to. So let's do another example with that. So let's say I had a number line. Let's go by 2's here. And I had a closed circle on 2, and I shaded to the left. So I know my X value has to be less than 2. So I know 2 is the largest number. So my sign must face the 2. And then again, we have a closed circle, so it has to be included. So that's why it's greater than or equal to or less than or equal to. So here it would be 2 is greater than or equal to X. So if it's a closed circle, again, it's right here. You got to include that number in the inequality. So that's what I'm trying to get you to understand with this example here. So let's go back to our original example. So we have, change color, this line segment. So I want to figure out what is my domain and what is my range. So let's say my domain, which is my X. So let's say this X value here is -4 and this X value here is 5. Let's say my Y value here would be 3 and my Y value here would be -3. Okay. So I want to find my domain. What is my domain? So our domain will be all our possible X values. So I'm looking at only the X value. So I'm looking at the horizontal line. So I'm looking for my highest and my lowest x value. My lowest x value will be -4. My highest x value will be a +5. So my domain will be, and again, you see these circles are closed. These points are closed points. So it's going to be -4, which is my lowest point. So it has to be -4 is less than or equal to x, because my domain is x, which is less than or equal to 5. That is my domain for this example. Then I must find the range. My range is all possible y values. So my possible y values will be, my lowest y value is -3. My highest y value is 3. So again, I want my lowest, -3, which is less than or equal to y, which is less than or equal to 3. So that is my domain and range for this example. Okay, let's try one last example of a graph. You have to identify the domain and range. So I know for 8th grade we haven't covered this yet, but well, we have covered it. We just haven't went into depth. Let's say I have a parabola. Okay. And this is my x value of my y value of 1. Okay. So I want to determine the domain and range of this parabola. So again, domain, let's write it again, is x values. And range is my y values. Okay. So the domain for this function is all my possible x values. As you can see, they have arrows here. That means this line or this parabola will continue going up in both directions. So will my x value stop? No, they will not. It will continue going. So again, if it continues going, or you see arrows, it means it's going to be all real numbers. Remember we wrote that in the table? All real numbers. Okay. Now my range will be my lowest and highest y value. So my lowest y value will be 1. So I know it's going to be 1, which is less than or equal to y. Now, does my y value stop? For this parabola, it does not. So that means it's going to be an infinity. So it's going to be 1 is less than or equal to y, which is less than or equal to infinity, which is a sideways 8. That will be the domain and range for this example. So again, if you see arrows, it means it continues to go. So anytime you see a parabola, the domain will be, well, if it's a parabola that opens up or down, because sometimes you may see it as left to right, but that's not a function. But if you see it opening up or opening down, the domain will be all real numbers, unless it has a dot, but it most likely will have arrows. And the range will be at wherever the lowest value is or highest. Here, the lowest value will be 1. But if the parabola opens downward, it means it will have a maximum value, which means the number will be here and in negative infinity will be on the other side.